Okay, so when you're happy with all the peaks and bases from the peak detect GUI, you can extract peak features from them. So peak features such as amplitude, peak duration, peak slopes, and other things. So let's open the peak features node. Let's connect the output here. So in the peak features node, it's important that you select the appropriate data column from which you want to extract peak features. So the peak detect node gets the indices of the peak of the peaks and bases, and then the peak features node will use those indices to pull out the various features from the curve that you choose here. So it's important that you choose a curve that makes sense. So let's go with the df over f, apply. Okay. And one way you can visualize this is through using a B-swarm plot. Okay, let's open this. Okay. And so these are the various peak features that were extracted by the peak features node. So for example, and these are all described in the documentation for the peak features node. So for example, this is peak feature amplitude relative to the base that is left of the peak. And this is peak amplitude relative to the base that is to the right of the peak. And this is peak amplitude relative to the mean y value of the bases. And then this is the peak amplitude relative to 0 in the curve. So you can multi-select many of these to plot at once. So let's, for example, just do that for now. If you have some categorical variables which you want to group them by for comparisons, you can choose them over here. Just for demonstration, I will do them based on salt type, anatomical position, which is one of the ROI columns that we created for this project. In the data point tracer, let us view df over f and UUID column. So this is where you have to choose what is unique about each of the data points that you want to plot, so that when you click them, the data point tracer knows how to get the information about that data point. So in this case, the peak feature is what is unique about all of these data points. It is not the curve, because each curve may have many peaks. So you want to choose this so that the data point tracer works properly. So let's choose that. And okay, I think that looks good. Let's apply. Okay, there we have it. So as you can see, we have these three colors for the the different anatomical positions that we have chosen to group them based on. And you can actually get labels for that if you look at the violin plots instead. So these violin plots actually correspond directly to the B-swarm plots that you see here, which is interactive. Here. And let's actually get a tight layout to, yeah, it's better. Yeah. So as you can see, so it's anterior, and basically most things were untagged, and then posterior here, and yeah, you can see that over here. Okay, so this is more of something that you can use to present, whereas this is an interactive form that's useful to explore your data. So let's open the data point tracer, and let's click on some points. So let's click on that, and over here. So in the data point tracer, it will actually highlight which peak that is from. So as you can see, this one has a value of 1. Yeah, that makes sense. The highest one is at 1.2. Let me see if I can. Yeah, that's at about 1.2. See what some of these lower ones look like down here. Yeah, those are pretty low values. And then down here. Yeah. Yeah, and similar to, I mean, the data point tracer elsewhere in Mesmerize, you can open an analysis graph to see, the entire history of parameters that were used to arrive at this data point. So here you can see that the peak detected node, an amplitude threshold, absolute amplitude threshold of 0.25 was set. The input to the derivative was a root data frame, so the main project data frame. It went through the Butterworth filter with these parameters, so in order of 3. This was the frequency divisor, this was the WN parameter, which is actually derived from the frequency divisor, and the sampling rate of the data. So that's something, this is something that's determined internally. You don't see it on the node itself. It was then normalized, and then the peak features were derived from the df over f data column. Okay. Yeah, so that is one thing that could be interesting to look at with peak features. Another thing that could be interesting is to see if you can find any associations between different groups using a scatter plot. So let's say, what do not this, separate x and y. So let's say amplitudes versus, say, falling slopes. What does it look like? Not too much interesting. Oh, there. Say, based on this, colors. Oh, we don't need colors actually. Right. So this is basically a plot of, amplitudes relative to 0 versus the falling slope of peaks. And sometimes you may be able to see interesting clusters of your data by playing around with this. So maybe like duration versus slope. Where is rising slope, and falling slope. Log x log y. Okay. And of course, if you choose both as the same thing, it's just going to be a straight line. So yeah, there could be. So actually, it looks like the area of the curve and the rising slope seem to have this almost linear relationship on a log-log scale. Oh, data point tracer, let's say df over f. Yeah. So yeah, there's you can get quite an interesting overview of your data by playing around with these plots from your peak features. Okay.